All right, ladies and gentlemen, welcome to Chapter 17. Chapter 17 is called Carboxylic acid. And how you name carboxylic acids depends on the carboxylic acid's position. It is the highest priority of all functional groups in this course. Oh my goodness. I got a screen issue here. Fix it. There we go. So that makes this carbon number 1, that makes this carbon number 1, and one of these is carbon 1. And we'll deal with what do you do when CO2H is sticking off of a ring. It's kind of the same story as what do you do if an aldehyde is sticking off of a ring. If that was the case, you called it a carbaldehyde. Here, you just call it a carboxylic acid. So there's a carboxylic acid sticking off this ring. Okay, so first one. Those methyls seem to be on carbon number 5 out of 7. 5,5-dimethyl. 7 carbons is hept. The new functional group is carboxylic acid, ends with oic acid. There you go. They're not too bad, these nomenclatures now. All the rules of bicyclo should be followed here. And I'm accepting 2 schools of thought in this next one, or the third one. I'm on the third one. I don't know why. I'm jumping around. I'm doing the third one. You can name it as if the carboxylic acid is not attached to the ring, and use all the rules as if it's not even there, and then add it after. Or you can make it priority number 1, although in bicyclo you can't go beyond bicyclo bridgeheads are number 1. You can't disobey that rule. But you can put the carboxylic acid as a high priority as your numbering. And once again, all of these discussions for a quarter of a point to get the numbering right, I don't think you should be stressing too much. So I'm going to name it both ways. If I'm doing the rings as if there's no carboxylic acid, then the pi bond has the highest priority, the alkene, and I should start on the bottom. So I'll do that one in red. 1, 2, 3. Oh, wait, it's the same. So I'm choosing between 1, 2, 3, where the pi bond's on 3 either way. And then there's the group. Now, if you're using carboxylic acid at the end, it's a group. And you're saying that's not the number 1 priority. I'm doing that in method first. So I think having a fluoro on number 1 is the better of the 2 reds so far. So I'm getting rid of the bottom red. It's coming back. The bottom red is going to be a different color later. I am naming it as if the carboxylic acid is not there. So the high priority would be the alkene. Both of the numbering systems I had put an alkene on 3. So now I got to go back to groups. And I got a fluoro on 1 and a carboxylic acid on 3. I'm going with a fluoro on 1. Okay, and that gets me 3, 4, 5, 6. My eraser's still on. 6 in red down here. And that would be some kind of, I'm going to put it over here, bicyclo. And the big ring, is that even the big ring I was doing? I didn't even talk about this way. Why would this be a foolish 2, 3, 4, 5? Why is that foolish? It would give us the same bridgehead number 1 and the same size ring that I'm going to, but this ring doesn't have a double bond in it, so I don't like it. Okay, so sticking with our system, 8, 9, 10, 11, 12. So it's some kind of a dodec. And there's an ene between 3 and 4. And that's the end of that story, except there's a fluoro in front. We're going 4, 4, 2. Adds to 10, plus 2 is 12. That's good. Fluoro on 1. We got stereos and alkene, stereocenters and alkene geometry we'll do later. And now you've got to tell me, by the way, there's a carboxylic acid on carbon 3. And you use a separate word, hey, just like the example we're running into over here. Kind of weird. And you say, on 3, there's a carboxylic acid. So why do we have this method? Why can't we just say 3-ene 3-oic acid? Why can't we just do that and be done with that and not do this at all? Why can't we do that? Wouldn't that be so nice? Why is it not good? One simple reason. Nomenclature gives you the count of the carbons with the name. You're going to be 1 carbon short. You can't have a carboxylic acid as part of a ring. Answer me why that can't be true, ever. Carboxylic acid, that carbon's at the end. It's got an OH on it. So it can't be part of a ring if you're at the end. All right, so this is right out. So that's why we need this system. And the other system says, actually, the other system's going to give us the same numbers, isn't it? The other system says carboxylic acid is priority number 1, and I want to keep it as low as possible. So I guess I got to go 1, 2, 3. It's going to end up the same. Okay? That was just unfortunate. I didn't pick a great example. So blue would give the same name as red. But like I'm saying, you can name it like the carboxylic acid wasn't there. This is the red name. And then add it at the end. Or name it like it's the high priority and put it at the end. And then the numbers will change normally. They won't here because they both ended up being the same. Look for other examples in videos. There's tons. And we got a fluoro. We got a stereo center on 1. Always practicing stereo centers 1. CH2 that goes to a C-double-C would be 2. This hits a bridge much earlier than 4. 4 on a wedge is nice, means R is wrong, therefore S. That one's done because the 4 was on a wedge. And here the 4 is on a dash. And the 1 would be C going to a C-double-C, the 2, the bridge earlier, 3 here. And that's straight up S. So that is 6S. And the double bond has a Z geometry. You can just write Z. It's the only double bond geometry, or you can write 3Z. Z or just 3Z or just Z. It's the only double bond of question. So that does that one. That's a lot of work. The easier one's the one above it. And there were 4, 2, 3, 4, 6, 7, 8, 9. So that's a non-adec. Non-adec 6-ene, and this one does end with oic acid. They all end with some kind of oic acid or ic acid. That's why we're in chapter 17. And this one's got a hydroxy on 4. Why do we have to go hydroxy instead of call this an alcohol? Because the carboxylic acid is more important. And we got a stereo center, and we got geometry of a double bond that's E. So E, stereo center is S is wrong, therefore, whoa, R is wrong, therefore S. Quickly doing stereo center. 1, 4, 2, 3. Not R, therefore S. What's the heck? Not a deck. That deck is a mistake. That's what that's for. Good question. Thank you. She asked what the deck is for. What the heck is the deck? It's a good translation. That would be 19 carbons, right? And no, she was right. We don't need 19. We have 9. So that's a very wide N. And another N, and another N, just like that. There you go. Non-16-oic acid. Then apparently we're going to sneak in a Krebs cycle intermediate. Anybody know an alternate name for Krebs cycle? There's 2 of them. Citric acid cycle is another one. Old name is the tricarboxylic acid cycle. I don't think anybody's using that. Maybe. So I started 1 there because then I'll get a group on 2. Can't call this a ketone because carboxylic acids are more important. 2, 4, 5. UPAC name says pentane dicarboxylic acid. That covers everything except for that ketone. I guess I didn't have to put it way over here. How do you say there's a group on 2 that's just a carbonyl group? I don't know. Have we done that? I don't think we've done that. It's new. It's not a hydroxy like the one above it here. Hydroxy. It's an oxo. Yeah, she remembered seeing oxo somewhere. We did it too. Oh, see? I don't even remember doing that. But we did it. Oxo. And no stereocenters, no nothing. So what you're going to have to do for the other name, which you need to know, must also know that good. What is this? Oh my, such good apple pie covers the first 1, 2, 3, 4, 6 dicarboxylic acid. There's a section in the book. There's the title is often acids to die for, DI for dicarboxylic acid. And you'll see them explained over and over again. And this just covers them. And remember, they're dicarboxylic acids, so you need how many carbons minimum? If you're going to have 2 carboxylic acids, what's your minimum number of carbons? Number of carbons is 2. These are in order. That's why it's a nice little mnemonic device. And it's for oxalic, malonic, succinic. I think that's going to come in handy above. Glutaric, I think that's going to come in handy right now. Adipic and pimelic. And these all end with acid. Okay? So this other name here is going to be based on glutaric acid. And they call it alpha keto, which is, I know it's not UPAC, but it's pretty darn obvious what they're trying to say. These are biochemists talking here. They forgot about the rules of nomenclature, which is, common. Very common for when you're dabbling in somebody else's field for you to take liberties with it. It's okay. It's your own thing. They call it alpha keto glutaric acid. You got to learn the glutaric acid part. It's just for your future that I'm making you do that. Those diacids show up in so many intermediates in your biochemistry classes. It's insane. And you're gonna know right away as soon as you see something with like a dip in its name. You're getting your fingers out, you're going, oh, well, you start here, right? Oh my, such good, a dip, apple. Yeah. 6, I'm gonna draw 6 carbons, carboxylic acid on each end if it's got a dip in its name. All right, and then whatever else they give you, throw it on there. Okay. So we got that. Some of you may have heard of alpha ketoglutarate acid. Not that important right now. And moving on to the next portion, this is a double points video here for sure. We're going to draw 6 in a row. And where are we going to put the 7th carbon? Remember, iso means at the end. Remember, the carboxylic acid is the anchor. That's number 1. There's got to be a V on the other end. So we do 6 in a row with the carboxylic acid. 2, 4, 6. You can go CO2H. And second from the end is where you put this to get the iso pattern, right? There you go. Next one, I'm doing a little heads up, but I kind of started the heads up on your test, I think. That's a group. I think you could draw that group without knowing amine nomenclature. It's an amine, so it's a nitrogen, right? And what else does the nitrogen have on it? It's in the parentheses. Just one? There you go. So whatever the chain is on the left there, and then we wanted to attach to 2 and 6. There's 2 of these things. So we're going to go pentadec. Finally, we got 15. 2, 4, 6, 8, 10, 12, 14, 15. Off of 5, there's a double bond. 1, 2, 3, 4, 5. Double bond to 6. Our geometry might look a little ugly, and it will. Because on 6, there's one of those dimethyl-aminos. The question is, does it go here? I want to say no, because that's going to be Z, isn't it? That's Z. Can't do it. I don't want to redraw my chain. What's your way out of this? Yeah, put it down here. It's got to be before that CH2 to the left. So you know that's the part that is E. This is E to this, right? And that's got to be up there. You're just admitting you made a mistake. That's fine. You don't have to redraw it. It got in between. And off of 6 is, that was 6. Off of 2, there's 2. We're going to need to put an N with 2 amine methyls on it and an H because it's a stereo center. And it needs to be R. I'll put the H on a wedge. No, my apologies. Put the H on a dash. Dimethylamino on the wedge. Because that's a 1 for nitrogen, a 2 for carbon, a 3 for carbon, and a 4 for hydrogen. There you go. And finishing strong, oh my such. Why did he start with oh my such? Oh my such. Such. How many carbons? O is 2, my is 3, such is 4. So a 4 carbon dicarboxylic right here. S2 amino. That's just straight up amino this time. And I believe, because we drew it on the bottom this time, it's going to go dash and wedge. As it goes 1, 2, 3, 4. A lot of students see the CO2H and automatically put it above the N because they see the O's. But the O's are not the thing attached, are they? It's the thing attached we do stereocenters on. And which amino acid is that? See, I remember you got aspartic acid and glutaric acid. No. aspartic and glutamic. See, I got confused by my own little thing here. Guess which one glutamic acid's based on? It ain't this one, because this has got 5 in a row, right? So why they didn't call this succamic acid to make your life easy? Because the next amino acid with one more C in here is called glutamic acid based on this name, and then they decided not to base the other one on this name. Why? They're not looking for excuses to make your life easy. The reason is always history, by the way. People, you know, they invested a lot of their lives in this, and their stories want to be told and all that stuff. But this one's just, it's which amino acid that? It's aspartic acid. Now, I don't make you memorize the 20 amino acids, but your first biochem teacher most likely will. So if you're solid on nomenclature and you're trying to memorize those 20 things where the only thing that changes is an R group, and you know naming R groups like the back of your hand because you've been doing it for 10 tests, you have a distinct advantage in just that exercise your teacher's making you do, learning the 20 amino acids. Other students are starting from scratch and they're just going on basic pattern recognition and they're 3 months behind you. Let's not do that. So I think we answered everything here. Oh, we didn't do this one? You're right, thank you. Yeah, didn't do that one yet. We're gonna sneak it in. It's not a hard one. We're gonna draw cyclohexene first. Just draw it because the name says R cyclohexene. Now, you got to remember the numbering system is number it now. Don't number it with the carboxylic acid yet. Number it first, then put the carboxylic acid. Now, if this is the only thing here, cyclohexene, see it's in the name, cyclohexene by itself. Where's number 1? It's got to be a double bond carbon, right? Where's number 2? The other double bond carbon. Where's 3? It's here. What's on 3? Now you can tell me. Carboxylic acid's on 3. And we have to make it R. So I think the H is on a wedge. That's on a dash. Big fat highlighter. There you go. Bad choice of color. I already had a pink highlighter there. I guess that's it for this. Okay. Coming back with a mechanism.